So, so basically going to go through questions for your supplementary. So it's just going to cover again everything nearly from study unit 1 to 11. And yeah, so let's just start. Okay, so again, you will see just going through some questions, going to give some tips, some things that you need to look out for. You will also, and I will share the presentation as well, because you will see in some instances I've added some notes and things like that as well, to just make it easier if you get a question like that. Okay, so let's start with the first question. So as your exam will also be, it will run from study unit 1 through to study unit 11. So these first few questions is around study unit 1, 2, and 3. Okay, so in this instance, we're looking at a question where they ask us which one of the following statements is incorrect, and regards to a statistic. Okay, so again, very importantly, from study unit 1 is when we talk about a statistic, we normally look at the sample. And normally how I would look at it is the S of a sample, the S of a statistic, and then it is normally, you will say a population and a parameter is going together. So let's quickly look at which one is incorrect. So a statistic is an estimate of a population parameter. Yes, that's true. So also remember, if we look at, say this is your population, sample will be a small part of that population. So a statistic will also be then an estimate of that population, because it will be looking at the sample. Okay, then a statistic represents a property of a population, not that of a sample. Okay, so statistic goes with sample, not with population. So that one is your incorrect one. Let's just look at why the others are also correct. A statistic is a summary measure calculated for sample. And so that is correct. Sample standard deviation is a statistic. Is correct. So if we had population standard deviation, that would have been a parameter then. But just remember, everything that is to do with a population would be a parameter. So they could have asked the same nearly question as a parameter is a summary measure calculated from a population, or a parameter. Population standard deviation is a parameter. A sample mean is a statistic, is correct again. Again, they could have said a population mean is a parameter. So just remember that the differences between a statistic and a parameter, where the statistic is linked to the sample and the parameter is linked to the population. Okay, so that nearly was at the start of study unit 1. And then from there in study unit 1, we go into different types of variables. Okay, so we check on those. We go into different types of variables. And in this instance, again, they ask us which one of the following statements is incorrect. So again, if you look at that, just be careful again in the exam, because one might nearly read it as you're looking for the correct one, and then the first one might be correct, and then you click and you go on. So just be very careful when you do the exam to see what they're asking, and don't make mistakes on that ground. Okay, so incorrect, and then we need to look at what types of variables this is. So let's look at the first one, and we'll go through all of them again. So quantitative variables, so it's looking at quantity, takes on values with equal units, numeric values that will indicate how much or how many. Okay, so quantitative is quantity, so it will indicate how much or how many. So so this one is correct. They say numeric values, so remember it can be 1.456, or it doesn't, they don't say continuous or discrete, they just say numeric values. So that does include both continuous and discrete. So that is why that one is definitely correct. So again, I think it's important when you guys, and I will share my summary pages again, so that you can just see when we look at quantitative, the continuous, discrete, just if there is, and you will see there is something coming through there in a question as well. Okay, so variables can be classified as categorical or numeric. That is correct. So you can have all categories, or you can have numeric values. So that is correct. Quantitative. So again, we're looking at quantity. Continuous variables result from counting attributes of an element. Okay, continuous means it, if it was discrete, it was 1, 2, 3, 4. Continuous means that there can be decimals, and then that is not counting attributes. So if it was discrete variable, then it would have been counting decimal or counting attributes, but when it is continuous, you can't. So the incorrect one is option 3. Okay, and let's just look at the other two. We already looked at numeric. So numeric variables can be either discrete or continuous, which is correct. Qualitative, so remember those were quantities. Qualitative about what goes on in the variables, uses labels or names to describe attributes of elements, which is correct. So if you nearly look at qualitative, look at that, it will describe the attribute. So it will use names and labels. So something like your eye color is a qualitative measurement, something like the color of your hair, which province you live in, all those kind of things will be a qualitative variable. Okay, so nearly started off with your differences between sample, population. Then we're looking at how to describe the data that you look at. And then the next one is nearly we're talking about some order in the measurement. So what I've added for you, and it might have been in some of the previous notes as well. So if I talk about your levels of scales of measurement, which is the highest and lowest level, you can use this diagram. And if you want to look at nearly what your variables can do, so if you have a nominal variable, you can only do nearly two things. If you have ordinal data, you can do more. You can add your median and mode. If you have interval, you can do more. And then if you do ratio, you can do much more. And that's why ratio will be the highest. Interval will be the second highest because you can do bit more with interval than with ordinal and nominal. So you can nearly look at this scale to say with nominal, you can do a few things. Ordinal, you can do those few things plus one or two things more. Interval, a bit more, and ratio, nearly everything. Okay, so let's look at this question. Which one of the following statements is again incorrect? With regard to variables and their scale of measurement. Okay, so let's look at the first one, a nominal scale of measurement. So we can already nearly look at those two. Is the weakest form. Okay, so yes, it is, while a ratio scale is the strongest form. Okay, so nominal weakest, ratio strongest. Correct. Okay, then we go to the next one. The mean and the median cannot be determined for a nominal scale. Nominal scale, so mean and median cannot be determined. Correct. We cannot. We can only look at the mode and counts or frequencies. So no, we can't look at median and mean for nominal. Quantitative continuous variables result from measuring attributes of an element. Okay, so now they've thrown in the previous question as well. So continuous variables results from measuring attributes of an element. Not 100% sure yet. So let's just look at the other two, and we might then relook that one. Ordinal scale of measurement is a higher level of measurement than interval. Ordinal higher than interval? No. The interval is higher than ordinal, so that one is incorrect. Quantitative discrete variables result from counting attributes of an element. Counting attributes, correct. Again, now we can look back. Quantitative continuous variables results from measuring attributes, which is also correct. So if it is discrete, it is counting. Continuous, it will be measuring. Okay, so that again is two things that you can also just merely highlight for yourself is um, the continuous will be looking at measuring, and your discrete will be looking at counting. Okay, I will share the presentation and the recording onto our group just after our session. Okay, so if we look at those kind of things, the first few questions was basically looking at study unit 1. So it was to look at the differences between population and sample and things that you need to know around that. Then it went into your for different types of variables, and then nearly going on with the different types of variables. But in this third question, it was looking at the scales of measurement. And that is nearly, they can again have scales of measurement with the types nearly combined into one. So here you can see some of the scales of measurement was option 1, 2, and 4, where the types was options 3 and 5. So again, they can combine it into one question if they want to. Okay, so that was basically study unit 1. Then study unit 2 starts looking at they tell you what variable it is. Then they tell you that you need to nearly look at that variable and represent it in a visual format. So study unit 2 was all about using or looking at the data, and then summarizing it in a way that you can visually look at your data. What we've also seen is, so in study unit 3, we will start looking at mean, median, and those kind of things. And they sometimes combine questions from study unit 2 and study unit 3 together. So like a box plot or something like that, or a stem and leaf, where they start asking you questions around the mean, median, and those kind of things, or Q1, Q3. So it's basically a combination of the two. So, but when we look at just data, and they tell us it's cumulative or it's with a frequency, then it is purely looking at the data with no other things connected to it. So let's first look at what they give us. So they give us data. They tell us it's cumulative. So the first thing I want to do is to get what is the frequency, because it might be that somewhere here, see, they will ask us things around frequency. So I first want to understand what's the frequency of each one. So let's look at it. So the first one, 6 to 8, cumulative is 4. So your frequency for the first one would be exactly the same. But then 9 to 11, cumulative frequency is 17. So to get your frequency, basically taking the 17 and you minus the previous one, which is 4. So that would be 13, the same, 42 minus the previous one, 48 minus the previous one, 50 minus the previous one. Okay, so that gives us the frequency, and then depending on if we need to look at percentage or something else, but let's now first look at some questions, and then we can look at other ways that we can add. I would not now go and also work out your percentage frequency for everyone, percentage cumulative frequency for everyone. I would keep it at these two, and then I would, as the need arises for the question, I would then work it out. Just again, we know the timing of the exam, you don't have a lot of time. So I would rather just look at the basic one I need to add, and then the other ones I will work out as the questions come up. Okay, so let's look at the percentage frequency of class 9 to 11. Okay, so percentage frequency, so it is 13 divided by 50, which is going to be 26%. Okay, so if you used the 17 divided by 50 would have given you 34, but then you're actually working out cumulative frequency and not frequency. Okay, so important here, they want the percentage frequency, so we need to work with frequency and not cumulative frequency. Okay, so the first one is incorrect. So in the exam, if you worked with cumulative, you probably would have said 34, first one correct. You wouldn't have looked at the rest, and you would have thought, okay, great, I've got it right. So just be very careful again, looking at the wording, please, because they again, there's some things that I want to catch you out with, and this is definitely one that I want to catch you out with by saying cumulative frequency, and you first need to work out the frequency. Okay, the midpoint for class 6 to 8 is 7. So basically, how I normally do it is 6, 7, 8. So the one in the middle is the midpoint. So the midpoint is 7. Okay, so if you look at, oh, sorry, which one is incorrect? Okay, so the first one would have been incorrect. So, so if you thought it would have been 34 and you said correct, okay, you would have, sorry, I can see it's still early. Okay, so the first one was incorrect, and that would have been then fine if you then just said incorrect and gone to the next question. It's still very early. I need more coffee. Okay, so midpoint between 6 and 8 is 7. Relative frequency. Okay, so now by saying relative frequency, so we're working again with frequency, not with cumulative, of class 18 to 20. 18 to 20 is 2. So 2 divided by 50. They don't ask us percentage. They just ask us the frequency, relative frequency. So that will be 0.04. So 2 divided by 50. Again, if you used cumulative, it would have been 100%. So then again, you would have made that mistake by saying that one is also incorrect. Okay. The width for each class is free. Okay, so here what is interesting, so, and let's just write the others down as well, or just two of the others. So when you look at the class width, sometimes one wants to say 8 minus 6 to get you 2, but that's not right. Okay, so what we're getting here is distances in kilometers. So the first one, and now I'm just gonna, I think there was a data set was given here as well. So you can see that, so the first one was, let's say from the data 6.2, then there's a, let's say a 7.4, and then there's a 8.7. All of those will fall into the 6 to 8, or it could have been that they rounded off. So let's say it was 8.4. Okay, so then what you see is you actually have that 8 point something part of your distance. So class width will then be all your 6s, all your 7s, all your 8s. So it will be 3. Okay, so just be very careful, especially when they say 6 to 8, then it includes the 8. It could also be, and just check some of your, it's in the study guide as well. So if they had, it's normally something like that. When it's a open bracket or a round bracket, it means 8, 8.1, 8 point. If it's a closed bracket, it means just up until 8. Okay, so if it was 6 up until 8, so 8 was the last one, 8.00001 would fall into the next category, then it would have been a different class width. But in this instance, we take all the numbers of 6, we take all the numbers of 7, we take all the numbers of 8. Okay. Then the last one, the frequency. So again, frequency. So you can see 3 of the questions was actually based on frequency. Nothing was based on cumulative frequency. So again, very important, nearly when you get a question like this, they tell you about cumulative frequency, please add the frequency for yourself. Okay, frequency of class 15 to 17, that was 6. So yes, frequency is 6. If it was relative frequency, it would have been 6 divided by 50. And if it was percentage frequency, it would have been the 6 divided by 50 times 100%. Okay, so again, that nearly covers all of the ones that we had with frequency as well. Okay, frequency is the number. Relative frequency is when you have a decimal number, and then percentage is when you look at it and you worked out the percentage. Okay, so this is the first one that we have around the data concept. But again, it is really looking at the data, and and analyzing the data with things that were asked. So again, I would just work out the frequency, and then as the questions come up, I will see what I need to add to it. Okay. Just again, I will share the recording and the slides with you just after the session. So I will share everything again with you guys so that you can go and relook what we've worked through. Okay, so now sometimes they do it the other way around, that they first give you the data, then you will do some summaries of it, because that visually and how the brain works, I normally do that. But in this instance, because of how your exam is run, first study units first, going to the last study unit, that's just for order of it. So let's look at what they give us, and then we look at some of the answers and how to get to certain things. Okay, so they give us some information. So this is very important in the instance that, okay, so they give us, okay, sorry, I want to see, it was going quite nicely up until a certain stage. Okay, so they tell us the sum of squared deviations around the mean has been calculated, and it is equal to 406.369. Which one of the following statements is incorrect with regard to the variance and the standard deviation? Okay, so they give us that sum of square. So if you look at your formulas, that I'll just check if I still have that formula page. How it works is that sum of squares, it's nearly something like that. And if you look at your variance formula, it's the sum of squares divided by n will give you your variance. Okay, so, and let's just see, looking at schools. Okay, so we're working with, sorry, just want to get this right for you guys. So we are working with a sample. Okay, so then to get that answer will be the 406.369 divided by how many there are. So it's 50. Okay, let me just, I don't have my calculator with me, so let me just quickly check on Excel. So 406.369 divided by 50. That will give us, let's just go into the draw function again. That will give us 8.127. Wait. Okay. And so that's the one thing that you also need to remember. So let me just quickly. And I hope it is again clear in the book. So when we, and I'll just make a note here for you. So when it is sample variance, it is that sum of squares and when it's the formula is n minus 1. When it is your population, it is just divided by n. Okay, so there's a small, and just make sure, so when we use and get the information, that you know which one to use. So in this one, we're working with sample. So we need to use the sample variation, which is 8.293. So sample variation variance is right. And then to get the standard deviation, it's just the square root of that. So the square root, I'm not going to rewrite the numbers, but the square root of 8.293 will give us 2.879799. So if we round it off, 2.80, 2.880, sorry, which is option. So let's just see what did they ask. Which of following statements is incorrect? Okay, so we know the two samples ones are correct. If they ask us to work out the populations one, it would have been exactly so population variance. So let's just do that. So it will be 406.369 divided by 50. Which is 8.12. So that one would be incorrect. So that would again be correct. And let's just look at that definition one. The variance is equal to the standard deviation squared, which is correct. So variance is equal to your standard deviation. Well, there you see it squared. And the same with the if it is population as well. So it doesn't matter which one, you will see the square coming in. So the variance is equal to the standard deviation squared. Okay, I just want to save. So that is on variance, standard deviation. If you get this big set of data, they are definitely not going to, they will give you other information so that you don't need to use Excel. It might be, and I think in the next one, we get a smaller data set that we need to work something out, then it will be that you might be able to use Excel as well. But if they will not give you this large data set and ask you to work out something, that will just not happen, because it's just to capture things again, it takes time. So they would rather give you information that you can use so that you remembered, okay, I need to use that formula or I need to use the other formula. Okay, so that is still on study unit 3, looking at your variances, your deviations of both, so both variance and standard deviation of sample and population, and nearly the difference in it is sample is n-1, where the population will be n. So this one is a very important formula in the instance that they give you nearly that top part, so that you need to know with what you need to divide with. Okay, then we go into the next one. So now we're getting a question around coefficient of variation. And yes, so got 5 numbers. And on that, they ask us the coefficient of variation. So just again, let's first look at what coefficient of variation is. It is standard deviation divided by the mean. Okay, so if they have given you in this questions standard deviation and mean, then you use it. Else now we see, okay, they don't give it to us. So what I would just do is I would put that data into Excel. So it's 100, 104, 110, 111, 112. Okay, so there we have the data set. Let's make it a bit bigger. We need to get a standard deviation, and we will need to get the mean. And if we have those two, we can work out the coefficient of variation, which is your standard deviation divided by your mean times 100%. I will share this as well, but I think you guys have my original in any case. Okay, so standard deviation, remember again, we're working with a sample. So this standard deviation needs to be of a sample. So there is a standard deviation formula, population or sample. We work with sample. So that's your 5 numbers. And then there isn't a mean function in Excel, but the mean is the same as average. So there is an average function. Okay, and there we have standard deviation divided by the mean. And let's just round it off to normally 3 numbers, 4.820. We look at it, 4.820. Okay, so unfortunately, again, I would not in the exam go and now work out nearly the hand method to say 100 minus, and first you would have needed to work out the mean, but 100 minus 107, what was it, 0.4, 0.2, 0.4, because that is how we would have needed to work out the standard deviation, if you remember that formula. So it is, I would have needed to say that plus then the next one, plus the next one, plus, so you needed to do 5 calculations then needed to divide it by n minus 1. So that would have given you your standard deviation, or not even your standard deviation, your variance. And then you needed to square root that. So please, if you get something like that, like this, for the 1510 guys that were not allowed to use Excel, they would probably give you these numbers if they ask you something like this. So they would probably give you those numbers like they would have given you in this instance. And for the 1610 guys that are allowed to use Excel, also rather use Excel or even the function within your calculator. So and that for the 1510 would have been also an option if you have a calculator to nearly use the calculator that you can put in the 5 data points and work all of these out with those 5 data points. Okay, let's go into the next one. So here now, nearly a summary of the things that you've done in study unit 3. This is looking at the box plot, and just things that we normally have in the box plot if I want to use it as a definition question. Is at the top you've got your maximum number. At the bottom you've got your minimum number. That first line of your box is Q1. The second line is Q2, which is also your median. And then your third line is Q3. Okay, so if sometimes a question is which of the following is not part of the 5 measurement scale or something like that, or the box plot scale, then I normally give you somewhere in here another thing like average or mode or something like that, and you need to pick that out in a definition kind of question. Okay, but max, Q3, Q2, Q1, minimum. So they've given me data. It's already sorted from smallest to highest. So what I would do in an instance like this is I would just first look at my lowest point is 115. Okay, so that's 100. So it can't be box plot A. 115, that's 80. Can't be box plot B. 100 can't be box plot C. 80 or even less than 80 can't be box plot D. Okay, that looks like 115, but there isn't a line. So let's just, why is that? That looks like 85 or something, so it's not that. So the only one that we have open is E, but let's look why there's no line. So, okay, so the next one is, and because we only have 5 numbers, that's Q1, that's Q2, that's Q3, that will be max, that will be min. So your minimum number is also Q1, which is right. Then 120 is the middle one, looks like 125. And then at 150, your max. Okay, so E is the correct one. So the next thing also very important, because now sometimes we would say, oh, cool, E got it is the right one. But then look at what it says. E box plot B. Oi. Okay, so now which one? Not box plot D, not A, E. So your correct answer is actually option C. So again, small things that you actually know your work, but nearly went for the wrong number because, again, rush for time, looking at it, very easily one can make that mistake of saying answer is E, but that actually reference to something different. Okay, cool. So that is box plot. So up until now, questions of study unit 1 to 3. So the next one, as you would remember, is we're going into probabilities. So let's go into probabilities. Again, also for the guys that are joining in between, I am recording. Just want to make sure. Yeah, I am recording. So I will share the recording on our group, and I will share the presentation as well. Okay, cool. So next question, we're looking at probabilities. So let's quickly see what they are asking us. So they're giving us data. They tell us 800 learners. There is an opening, so we need to complete that. But let's wait until we get something with primary and less than to do that. So first we went high school and less. Okay, and we're looking for incorrect one. Events high school and less than 3 kilometers are not independent. Okay, so is the easy way to do that? Let's first look at the others, because we will need to work out for that one is the probability of A times the probability of B. And you will remember from your independence rules, is that equal to probability of A and B? Okay, so that is a calculation that we need to make. So let's do it. I would normally first look at other options. So let's first look at a few other options that we just can see if there's things that we can eliminate before we need to work out anything. The probability that a random chosen learner is in high school and travels, okay, there we also need to do a calculation. The events less than 3 kilometers, between 3 and 6, and greater than 6 are complementary. Okay, so that is correct. So remember, complementary normally is if the probability of A, and the complementary of that would have been 1 minus the probability of A. So basically, if you're not in A, you're in the other one. So if you're not less than 3, you're in one of the others. 2, If you're in between 3 and 6, if you're not in there, you're in the other two. If you're not in greater than, you're in the other two. So the events less than, between, and greater will be complementary. The same with primary and high school. Those two are also complementary. So in this sample, if you're not in primary school, you will be in high school. Okay, so doesn't matter if you look at it between the kilometers, that is complementary, but between the types of schools is also complementary. Then events primary school and high school are mutually exclusive. Correct. So you can't be in primary school and high school at the same time. The same with the distances. You can't be less than 3 kilometers away from school, but also between 3 and 6, and also greater than 6. So you can only fall into one of those. So again, less than, between, and greater will also be mutually exclusive. Okay, so at least the two definition ones are sorted, but we're still looking for the incorrect one. And then the probability that a random chosen learner, okay, so there also. So for that, A, B, and E, we will need to make calculations. Okay, so let's start at the top. Probability of A, so the probability of high school. Okay, so we will now need to start adding numbers. So now it is time to put in that one. So that will be 72. So if you add all of the numbers, subtract it from 800, you will get that number of 72. So if we add 72 plus 168 plus 240, that will give us 480. Then if we add 48, 112, 160, that will give us 320. Okay, so events high school. High school is 320 over 800 times probability of what is the other one, less than 3 kilometers. So if we get that, that's 120. Okay, so let's see what is. I'm just, again, I would normally use my calculator. I don't have my calculator with me. So 320 divided by 800. That gives me 0.4. 120 divided by 800 gives me 0.15. And then if I multiply those two together, I will get 0.06. And if this now is independent, it will be equal to 120 divided by 800. So I'm first checking if it is, sorry, not, remember we're looking for the and, which is 48. So 48 divided by 800 is 0.06, which is the same. So the two are independent. Okay, the events high school and less than are not independent. Okay, so it is independent. So I have the one that is incorrect because it is independent and not independent. Okay, so option A is the wrong one. But let's just work out the other two. Probability that a random school learner is in high school. And that's probably the easiest one to work out is probability of high school is 320. So 320 divided by 800 is 0.4. The probability that a random chosen learner in high school and travel less, so actually they've given us to work out that also. So we've done it already. It's the 48 divided by the 800, which is 0.06. Okay, so the one that is incorrect is the events high school and less than are not independent. So it should be that they are independent. Okay, so this one on probability, it took us quite a while to work it out. Yeah, in the exam again, because this is something that is really time consuming, I would probably have done the same again. I would probably have looked at the two definition type of questions, and then I will just start at the top um, and see which one is the incorrect one. And again, in the exam, if I get that one as not correct, I will probably not go to question B and E even to look for it. Just because again, I think what is it, 25 questions in 2 hours. So yeah, it certain times you need to nearly look at options to make it easier and eliminate certain answers. So again, please don't, if you have worked it out and your first one is the incorrect one, please don't check your question nearly unless you have enough time. Again, I don't want you guys to run out of time nearly. The problem is, again, with the stats questions is you can't go back. So if you've done it, you can't go back and recorrect it. So it's a fine line between checking and not have enough time. Okay, next question. So I just want to move it so that we can see. So what I have added here is also on the shape of your distribution. So now you can see we actually only did one on probability. Okay, one on probability. Now we're going into shape of distribution. So again, if this will be for your normal distribution, so they can ask it at study unit 3 nearly where you've done your mean, median, and mode, or they can ask it when you start with study unit 6 around your normal distributions. So it might be early in the paper, it might be late in the paper. Okay, so negatively skewed. So when we have negative skew, wait, let me just, and again, please use these notes. You are allowed to use it. So let me just not, so that you can see that when I share it. So negatively skewed, the mean is less than the median? Yes. And the median is less than the mode. Okay, cool. Correct. Okay, so in the exam, perfect. First one solved. We go on to just again look at that we specifically, if I do this, have option 1, 2, that it's not swapped around. Okay, let's just look at the other ones. The mean is greater than the median, and the median is greater than the mode. So that one is positively skewed. And again, with the differences in papers, it might be that the one of you get negatively skewed, one of the other papers is positively skewed, and then when the mean, median, and mode are all equal, we've got the bell shape. So it might be that between the three papers that are around, they ask one of those as being the correct one. Okay, then the other two is just the mean is greater than the mode, which in turn is greater than the median. Okay, so that one is just confusing. The mean is less than the mode, which in turn is less than the median. Okay, so they just basically every time move the mode between the, so those two are definitely wrong. So another way to simplify it for you is to see its mode, median, and mean. Mode, median, and mean. Okay, so the order is always mode, median, mean, mode, median, mean, mode, median, mean. So, or if you want to do it from the other way, the mean is less, is less, is less. Okay. But please use this diagram. I will share it with you guys on the chat. So let me just clean it up a bit for you as well, so that you can use it when needed. Okay. So please use it. You are allowed to use it. So I'm also just quickly just going to make it a bit bigger for you. Okay, cool. Okay, next one. And so now we go into study unit 5, discrete, binomial, and Poisson. So and with discrete, we can have a few different things that they ask. So let's check this one. The distance from home to school okay, no, so this is oh, sorry, this is a probability question. So let me just move it with the probabilities. Sorry about that. I was wondering why I had so, oh yeah, let me quickly. Wondering why I had so few probability questions, not normally. Okay, so let's first do the two other probabilities, and then we can get into this discrete and those kind of things. Okay. Consider events A and B are mutually exclusive. So whenever we look at mutually exclusive, remember that A and B is equal to 0. So if we have probability of A as 0.35, and we've got probability of B as 0.65, what is the probability of the OR? So if you add those two together, we get 1. So not that one. Okay, so actually in this instance 1, but again, it could have been 0.25 and 0.55. Just remember the important thing, when it's mutually exclusive, your AND is always 0. Okay, so that was basically what I wanted to show with this question. The other one is going to be independent. So again, if something is independent, the AND is the probability of A times probability of B. Okay. So if it is independent, it's the probability of A times the probability of B. So in this instance, it would have been 0.35 times 0.65, which is 0.2275. Interesting, there is an option like that, but obviously we're looking for the OR. If we were looking for the AND, that would have been correct. Okay, but the OR, so 0.35 plus 0.65 minus 0.2275. Okay, so that was 1 minus 0.2275, which is option 5. Plus that would be 0.7725. Okay. Cool. So again, probability bigger than 1, not gonna happen. The other ones, that was our previous answer. And sure, if you want to subtract those two from one another, one can get to 0.3. Okay. Important thing, mutually exclusive. The AND is 0. When it's independent, the AND is basically the 1 times the other one. Okay. Now let's get into this one, which was also probability. I just saw this table and thought it was discrete. So let's look at the questions. Okay. So they tell us the distance from home to school is presented by this. Let W be the event that the distance from home to school is less than 3 kilometers. So what is the probability that event W, determine probability event W occurring and choose the answer. Okay. Less than 3 kilometers. 1, 2, 3. And let's just check. Okay, it was ordered, so there's no other one. So less than 3. And let's just see how many there are. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, so this one was actually nearly straightforward. The probability of less than 3 is then 0.3. Less than 4 would have been that one added, so it would have been 0.4. Less than 5, less than 6, less than 9, less than 11. So depending on what they ask, they could have said something. What's the probability that it is between 3 and 6? Okay, so what's the probability between 3 and 6? Then it could have been, and let's see how many is between 3 and 6. There's 1, there's 2, there's 3. So probability between 3 and 6 is also 3/10. Okay. So again, they can ask it with that same data but differently. So again, in the exam, what they will probably do is the people writing 1 would have less than 3. The people writing another one might have more than 8. And it might be that the people writing the 3rd or 4th paper, it is between 3 and 6 or something like that. So again, it might be that you can have 3 different questions based on the same information. Okay, so that basically now finally is the probability done. We have looked at this one. Okay, so now we go, and we've got about 13 minutes left. We go into discrete. So we're going into study unit 5, discrete binomial Poisson. What I've also added here is this table. And again, I will share the slides and I will share the recording afterwards. But again, I like to use this table because English not my first language. So when they start throwing in all of these is equal to fewer than at most, I start getting confused. So use the table, please. If you can print it, have it as notes with you, please do that. For the 1610, I know you guys are allowed again to have other things open. 1510, they said no. So please, if you can have it printed, then at least you have it as a nice reference when you need to look at it. Okay, so let's look at the options. The probability that 2 learners are absent on any given day is 0.2. Okay, probability 2 learners, 0.2, correct. Okay, unfortunately, I'm looking for the incorrect one. The probability that between 2 and 5 learners are absent is 0.4. Assume 2 and 5 are not inclusive. Okay, so we're not looking at 2, we're not looking at 5, we're only looking at 3 and 4. Okay, so between 3 and 4, or between 2 and 5 is looking at 3 and 4. So 0.3 plus that 0.15 is 0.45. Okay. The probability that at most 2 learners are absent. Okay, let's check. At most 2. So at most 2, so small or equal to 2. Okay, at most 2, let's check and let's take that out. Small or equal to 2, so it is those Those three, 0.2, 0.2 plus 0.1 is 0.5. Okay, correct. And that's why I like this table, so that one can really easily, the probability that at least bigger or equal to 2. So now it changes around. Okay, so at least 2. Important, it does still include 2. Okay, still include 2. Okay, so it's 0.2 plus 0.3 is 0.5, 0.65, 0.7. Okay, they say it must be 0.5. Okay, so that is the wrong one. It should be 0.7. Okay, so if it was at least 3, it would have been 0.5. But at least 2, we need to include 2. The probability that between 2 and 5 learners are absent on a given day, assume 2 and 5 are both inclusive. Okay, so now we're looking at from 2 to 5. Okay, so now you can nearly see that is the same as what the probability of at least 2 would have been. Okay, so at least 2 would have given you that between 2 and 5 would have given you the same one where it was inclusive. Okay, so very important, and they love to ask this. It might be that they ask it in some of the other questions as well, but please use this table. It just makes it so much easier to look at what you need to get to. Okay, so let's look at the last one for today. Again, we can use the table. The South African Embassy in Sydney knows that voter turnout rate is 91% at their station. In a random sample of 20 voters, what is the probability that at most 13? At most. So what's the probability that you will get X smaller or equal to 13? What's the probability that at most 13 voters will turn out? Hint, the number of voters is N is 30, or sorry, N is 20. X will be equal to 13. Okay, so now I think this one is actually wrong. At most 13, so you now need to go and check from your probability table of binomial, what is the probability of X smaller or equal to 13? I don't think I have it on my laptop at the moment, so I will just let's quickly see if I can Google something. So what is that? That is binomial distribution. So let's quickly see binomial. I actually got now a calculator, so but I would normally use the tables. I will quickly Google the tables as well. So n is 20, x is 13. The probability was 0.91. I just want to see. So we said smaller or equal to, so 0,00129, 0,00129. So if I round that off to 4 decimals, it will be option 5. Okay, so I just Googled, let me quickly add this in the chat so that if you guys want to quickly grab that, but you can also see, let me also just paste that in here so that you guys can at least get that one. But also, if you want to use the tables, let's just quickly binomial. N was 20. Okay, so N was 20. So this is online. So see somewhere between 0.9 and you can see again most of the data is sitting after the 13. So you can see very little is sitting here. So it's probably somewhere there. So again, when you look at the tables, you will see that the area we're looking at, less than 13, is very small. Okay, so that is why that answer also. So, but look at your binomial table that you have in your study guides. It will be in there the 0.91. Again, they will not ask you a number that is not on your tables. So if the 20n is 20 is not in the tables in your study guide, they will not ask it in the exam. Okay, so they will not ask a weird number like n is 18 when you don't have it. Okay, they will only ask you on what you have available in your study guides. Okay, so that is it for today. We will continue somewhere in the week, and it will be before 1510 rights. Let me just, I think 1510 rights on Friday, 1610 rights on Monday. So it will be probably Wednesday. But I will share a few options on the chat again with you guys. Okay. I will share both the slides and the recording in the next half hour on our chat as well, so that you have access to that. Okay, guys, good luck with the prep, and see you again next week. Okay, have a good weekend.
Thanks. Cheers, man.
Thank
Bye
you,
bye.
John.
Cool. Thanks, everyone. Cheers.